So now I'm going to do another example of weighted average. And this example is also very much worth your while. It's the other incredibly important one in interpreting integrals. And it's a very, very simple example of a function f. The weightings will be different, but the functions f will be of a very particular kind. Namely, the function f will practically be a constant, but not quite. It's going to be a constant on one interval and then 0 on the rest. So we'll do those weighted averages now. Now, this subject is called probability. In probability, what we do, well, I'm just going to give some examples here. I'm going to pick a point in quotation marks at random in the region y less than x less than 1 minus x squared. That's this shape here. Well, let's draw it up here. Let's draw it right down here for now. So somewhere in here, some point x comma y. And then I need to tell you according to what this random really means. This is proportional to area, if you like. Proportional to area. So area inside of this section. And then the question that we're going to answer right now is, what is the chance that, or it's usually called probability, that x is bigger than a half? Now let me show you that what's going on here, and this is always the case with things in probability. So first of all, we have a name for this. This is called the probability that x is bigger than a half. And so that's what it's called in our notation here. And what it is the probability is always equal to the part divided by the whole. It's a ratio, just like the one over there. And which is the part and which is the whole? Well, in this picture, the whole is the whole parabola, and the part is the section, x bigger than 1/2. And it's just the ratio of those two areas. Let's write that down. That's the integral from 1/2 to 1 of 1 minus x squared dx divided by the integral from -1 to 1, 1 minus x squared dx. And again, the weighting factor here is 1 minus x squared. And to be a little bit more specific here, the starting point A is -1, and the end point is +1. All right, so this is the probability that x is less than 1/2. And if you work it out, it turns out to be 5/18. We won't do it. All right? Yeah?
So this weighting factor of 1 minus x squared, I don't see quite how that's the case, because really the function is either 0 or that, correct? Because if your interval goes from -1 to 1, but you're only integrating on the top from 1/2 to 1, it seems like the weighting factor is something that's making the -1 to 1/2 integral 0.
What we're trying to do with probability, I can't repeat your question, but I can try to say, because it was a little bit too complicated. but it was not correct, okay? What we're taking is we have two possible things that could happen. Either, let's put it this way, let's make it a gamble. Somebody picks a point in here at random, and we're trying to figure out what your chances are of winning. In other words, the chances that the person picks something in here versus something in there, all right? And the interesting thing is, so what percent of the time do you win? The answer is it's some fraction of 1. And in order to figure that out, I have to figure out the total area here versus the total of the entire, all the way from -1 to 1, the beginning to the end. All right? So in the numerator, I put success, and in the denominator, I put all possibilities. So that, right? And that's the interpretation of this. So maybe I didn't understand your question. Why is 1 minus x squared the weighting factor? That has to do with how you compute areas under curves. The curve here is y is equal to 1 minus x squared. And so in order to calculate how much area is between 1/2 and 1, I have to integrate. That's the interpretation of this. This is the area under that curve, this integral. And the denominator is the area under the whole thing. Okay? Yeah, another question. Yikes. It was supposed to be the same question as over here. Thank you. This has something to do with weighting factors. Here's the weight factor. Well, it's the relative importance from the point of view of this probability of these places versus those. That is, so this is a weighting factor because it's telling me that in some sense, this number 5/18, yeah, actually, that makes me think that this number is probably wrong. Well, I'll let you calculate it out. It looks like it should be less than 1/4 here because this is 1/4 of the total distance and there's a little less in here than there is in the middle. So in fact, it probably should be less than 1/4, the answer.
Okay, but the equation of the line is 1 minus x squared, right?
The equation of the curve is 1 minus x squared.
And that's also the weighting factor?
The reason why it's the weighting factor is that we're interpreting, the question has to do with the area under that curve. And so this is showing us how much is relatively important versus how much is not. These parts are relatively important, these parts are less important according to area, because we said that area is the way we're making the choice.